So if we consider a factorable trinomial like this, we can write it as a term times a term, and it'll have the form of x in both of our terms with some coefficients. Let's just call these generic coefficients as n, a constant term, another coefficient, and another constant term, where all these constant terms are all members of the integers. Now our goal here is to eventually find the values of n, j, m, and k. If we can do that, then we're able to say we have factored this trinomial up here. So to do that, let's consider this trinomial up here as the area of a rectangle. So we've got a rectangle. And if it's a rectangle, it has the area of this guy here. So this is the area of our rectangle. And it must have side lengths of our two factors. So this is going to be nx plus j. This will be mx plus k. And maybe this length here corresponds to nx, and this length here corresponds to mx. So I can make some divisions in my rectangle, maybe down here and down here. And kind of following this through then, this rectangle here will have an area of m times n times our x squared, x times x. And this guy here will have an area of mj times x. Here, k, n times x. And this one will be k times j. Now the area then can also be expressed as the sum of these terms here. These four terms make up the rectangle. Now the goal here is to now eventually figure out the value of this term, of this term, of this term, of this term. That's helpful because if I can find these four values, the four values that I've circled, then I'll be able to find the values of n, j, m, and k. Now why is that? Well, if I have the value of mn and mj, then I see m is common to both of these, I can find the value of m. If I have the value of kn, and kj, I see that k is a common factor, I can find the value of k. And for the same reason, I can find the value of n, and I can find the value of j. So once I have the values of the orange things in this box, once I have this value, this value, this value, and this value, I can factor my trinomial. So my new goal becomes to find the value of these three terms here. Well, the first and last one are fairly straightforward. From these equations here, I can see that the value of A is the value of mn, and the value of C is the value of kj. So that's, I can write that down. So then A is my value of mn, and C is my value of kj. I also see some relationship involving mj and kn in that these two terms must equal my b right here. So b must be equal to mj plus kn. One more math trick here. If I multiply these two here, something interesting happens. If I multiply a and c, I get ac equals mn times kj. Remember, my goal here is to find the value of mn of these two terms. I've already figured out the value of mn and kj. So I now have two equations for b and for ac. And that'll be enough to let me figure out my middle two terms. So keeping that in mind, that I can express this b value as this sum, and those same two numbers these same numbers here, these numbers here, can also be expressed as a product of A and C. It gives me a method to factor this guy here. So I can write this then as ax squared plus c. And then my middle term, I'm going to find terms here where this term here and this term here, which eventually will become b, have the property that their product is A and C and their sum is b. So these two terms here have to add to be this guy and multiply to be A and C. Once we have those terms, we can do some factoring as outlined here to figure out each component of our factored trinomial.